Okay, so we're going to start off with workshop number 5 that has to do with homework task 6, and we've got a few problems here. So let's start off with problem 20, and that's house algebras. The first set of problems have to do with identifying or defining the domain of a series of functions. So let's go through those. So house algebras, please go ahead. There we go. Fernanda's sharing. Please go ahead. Okay, please go ahead.
Yes, I'm going to explain this one. Well, they gave us a function, so I decided. We decided to determine the defined range, and then we equal the equation to 0, so that we could swap the sides, and by setting the numerator to 0. Then we started to despejar. I don't know how to say it in English. And then
Solve. When we say despejar, we say solve. Despejar X means solve. We say solve for X.
To solve the equation, and then with the results that we got, that is 3 and minus 3, we substituted in the equations that we have on the top right corner, and that's how we got our two solutions.
Okay. Okay. Thank you, guys. Leave it here on the screen. We got to check a few things here. Okay. So I'm going to say this: you have all of the information to solve the problem. You didn't present the solution to the problem, and let's look at why. What is the what are these problems asking us to find? What do the instructions say? Let's read the instructions. What do the instructions say for these problems? Anybody from Team Algebras? What do the instructions specifically say? I'm not saying what you did was wrong, by the way. What you did was correct. You haven't presented the solution yet because of what's being asked. So what do the instructions say?
To find the domain, I think. Yes.
Okay. Yes, correct. So let's work with that a little bit. Let's don't remove this slide, please. What we're trying to find in these first exercises is to find the domain of the function. To find the domain of the function. That's what we're looking for. And so let's just write this down here. Find the domain of X, or the domain of the function. Okay. Now, anybody, give me a different. We're gonna repeat and pound this in. Okay. This is like one of those football games where what you want to do is tire down the defense, so you just keep running and pounding the ball. That's what we're going to be doing. We're going to be pounding this until it sets into everybody. Can somebody give me the definition of the domain of a function? Anybody? What is the domain of a function? What did we talk about with regards to the domain? What is the domain of a function?
Set of all possible inputs for a function. It's
the set of all possible inputs. Let's say it this way. It's the set of all possible values of X. Okay. It's the set of all possible values of X. Are we okay up to that point? That's the definition of domain. Now, what are the two situations, the only two situations that generate a conflict with the domain, that generate values that cannot be a part of the domain? Can somebody tell me one of the two situations that we mentioned in class?
The denominator cannot be 0 and
correct.
the cannot be Negative.
Correct, Leo. Well done. There's only two situations that we have to look for. And I'm going to pound that in because those are the only two situations. Whatever else is valid. There's only two situations that we're worried about. The denominator cannot be zero, and an even root cannot be negative. So now let's look at the function here that we're talking about. Let's look at the function here. This is our function. Do we have a quotient there? Do we have something in the denominator there? Yes or no? It's a very simple question. It's just a binary question. Yes or no? Do we have a quotient there? Do we have something in the denominator? Yes or no? The answer is yes.
Well,
I want to ask it again. Maybe the audio isn't good. Do we have something in the denominator in that function? Yes or no?
yes.
Yes. What is in the denominator? Can somebody tell me?
A Romeo.
The polynomial. It's this polynomial here. It's this polynomial here. And what is the restriction that we have?
The denominator is not zero, so we can factorize.
Correct. So I'm gonna do this. I'm gonna bring this over here. X squared. The only restriction. Do we have a root in that function? Do we have a root of any kind in that function? Yes or no?
Yes, from X.
No. Do we have a root in that function? Look at the function. Do we have a root there? Let's see. Let's see house algebras. Fernanda, Alfredo, Arturo, and Daniel. Do we have a root there in that function anywhere?
No.
No, we don't, right? So the only restriction we have is that x squared minus 2x minus 1 cannot be 0. Are we okay up to that point? Remember, just answer yes or no, so I know that somebody's there. Are we okay up to that point?
Yes, yes.
Okay, so what do we need to find? We need to find the values that make x squared minus 2x minus 1 0. And you guys already found them, right? They are these two values here, right?
3 and minus 3 are,
Can you say that again, please?
I said 3 and minus 3, but they aren't.
3 and minus 3 make what 0?
The denominator, they make the
No.
denominator 0.
Not the denominator. Denominator is in the bottom. Numerator is in the top.
The function.
3 and 3 make what 0? Make the numerator 0 and make the function 0. Is that valid? Yes or no?
Yes.
Then why are we excluding them from the domain? We don't care. We don't care that the numerator is 0. The numerator can be 0. The function can be 0. So we really don't care about the 3 and the minus 3. Remember, the domain are the possible values of x. Or rather, you're looking for the values of x that make, yes, Daniel, go ahead. They're the possible values of x. We're looking for the possible values of x that make the function not valid. And in that case, it's going to be the values of x that make the denominator 0 or make a root negative, okay? So we really don't care that the function is equal to 0. The function can be equal to 0. What we don't want is the denominator to be equal to 0. And you guys found the two values that make the denominator 0. And those values are the square root of, those values are 1 plus minus the square root Mhm. Making a mess here. Let me write this down again. There we go. There are these two values that you guys found over here. Move my screen is blocking what I want to write on. Okay, there we go. The values that make the denominator 0 are these two values that we have here. Okay. So I'm going to ask you guys, what would the solution be? Let's see house algebras. Anybody from house algebras? What would the solution be then? Let's see, I'm going to help you guys out.
Sure, may I say?
Go ahead, Luis.
It's because I don't know exactly how to say it in English.
Try it out in Spanish and we'll translate. But
I guess it is that X pertenece a todos los números reales excepto de 3 y menos 3.
no, again, you guys, we don't care about the 3 and -3.
What was the question?
But let's go back. I just want to finish up with what Luis was saying. We don't care about the 3 and -3. The 3 and -3 make the function 0. That is not a problem. We're looking for the values that invalidate the function. And those are the values that make the denominator 0. So I'm going to ask the question again. What would be the solution to this? What would be the domain of f of x? And I'm going to give you a tip. The domain of f of x is from -infinite to infinite, but we have to remove the values that make the function invalid. And we already have those values there. So I ask again, what is the domain of the function? Let's see. You guys are quiet today. Let's see. Fernanda, you're over there. You're part of house algebras, right?
Yeah.
Okay, so let's see if we're okay up to this point. We're finding the domain of the function, okay? And the only thing we care about when we're finding the domain of the function is to identify values that make the function invalid, and we're going to remove those from the -infinite to infinite, okay? We only want valid values. The only two Fernanda, could you repeat the only two situations that make the function invalid?
X equals.
Oh, Fernanda.
What we're doing or in general?
In general, what are the two things that make a function invalid that we're looking for? That are-
That the denominator can't be 0, and when you have a root, it can be negative.
Perfect. Now, for this situation right here, what are we seeing in this function? What are we? What would make the function invalid?
If the denominator is 0.
Correct. And that means that the denominator, which is x squared minus 2x minus 1, has to be different than 0. And you guys found the two roots, which is 1. Those two values, Fernanda, would you agree that those are the two values that make the denominator 0? These two values here? Is that part clear?
Yes.
Okay, so I ask you, Fernanda, what would be then the solution? What would be the domain of the function then? And I'm going to give you a tip. The domain of the function is all of the numbers except those two. How would we represent that?
Negative infinite.
I'm going to write it down while you're saying it. -infinite.
So you have to solve the square root that root that's in the x.
No, we can say it literally like it is like that. 1 plus square root of 2. We can represent it like that. You don't need to do the sum.
Negative infinite, comma, 1 minus root of 2. Is this going to be parenthesis or bracket? Parenthesis.
Parenthesis, correct, because they're excluded. Next.
The u and parentheses 1 plus plus root of 2, comma, infinite parentheses.
I'm gonna write it down and then we're gonna do a small correction. This is what you said, right? But you're excluding the values between these two.
Um,
The only thing we're doing is eliminating those two values. So what would be next here, Fernanda?
1 minus root of 2, comma, 1 plus root of 2.
Mhm. And then to finish up,
Parentheses, and then 1 plus root of 2, comma, infinite.
infinite. Correct. Was that clear, Fernanda?
Yes.
Okay, let me write that down again, but I'm gonna write it down with more space so it doesn't. So the solution would be from minus infinite to 1 minus square root of 2 union 1 minus square root of 2 comma 1 plus square root of 2 union 1 plus square root of 2 comma infinite. Okay. Which are these two values that you guys found. Just be very careful, you guys. Again, we don't care about the values that make the numerator 0. That is valid. We can have the numerator be 0. We just can't have the denominator be 0. And we can't have negative roots. Okay. So let me take a quick screenshot of this. Questions with this one before we move on? Questions with this one before we move on? Go on. Go ahead.
The roots you from 1 minus 2, you got them from solving for x.
Yes, for solving the denominator, solving the x squared minus 2x minus 1. I believe you guys got these. I'm gonna put them over here. I believe you guys got these using the general formula.
And it will always gonna be with parentheses because they can be those numbers.
Correct. We exclude them. We're excluding them because if we put them in the domain, or if we include them in the domain,
It's gonna be 0.
the denominator is going to be 0, and that cannot happen.
It's gonna always be parentheses, or there could be specific cases where it can be brackets.
Usually when we identify certain values, it's going to be, they're usually going to be parentheses because we're excluding them from the domain, because somehow those values, if it's the case of the denominator, that we're probably going to always use parentheses because we need to exclude them. If we're looking at a square root or an even root, it depends, because if the root is in the numerator, then it's not a problem. They can be 0 and they would be brackets. But if it's in the denominator, we would have to exclude them because it makes it 0 and it would be parentheses. And I believe that in some of in a few of the further exercises, there's some cases of that. Okay.
I have a question.
Let me just take another screenshot. There we go. Go ahead. Yes. Who is it? Remember to turn on your cameras if you're participating, so you jump up on the screen. It's Leo, right?
Yes.
Leo, go ahead.
I have a question. You did it like you like the x squared minus 2x minus 1. It cannot be 0. It's only in this case that the function cannot be 0, because I have the question that you have to do that in every function, even though if it has a root, like
the thing here, Leo, that we're looking at, we're not looking at the whole function. The whole function can be 0. That's not a problem. The denominator can't be 0.
Okay.
That's the thing. So for example, just to give you an example, if the function would be, let's imagine that the function that we're looking at is x squared minus 2x minus 1. Again, the things you guys have to answer yourself when you're looking at the function. Does it have a denominator? Yes or no? No, right? Does it have a root? No. Then the domain is from minus infinite to infinite. Now, if I do this and put a 1 on top, now we're in trouble because the polynomial is in the denominator. We have to exclude the values that make the denominator 0. Okay, those are the only ones. That's why when in the solution that was presented, we have the x squared minus 9 in the numerator. And we know that 3 and minus 3 make that 0. We don't care about those because the numerator can be 0. That's not a problem. Only the denominator is the one that can't be 0 because that generates an invalid number. Okay, is that clear, Leo?
Yes, it's because I did problem 24 and it got me like tricky in like the rules and that stuff, but I will ask you when it's my turn to present it.
Yeah, remember that the idea for the workshops is this. I don't necessarily expect you guys to have solved all of them perfectly, but if you have questions, the idea is that we can solve them here. So remember one thing that's important, you guys, everybody, we're doing the workshops, but in Blackboard, there is a folder for the workshops that has all of the complete correct solutions after we do the workshop. So even if you have a little mistake or detail, we're going to have the correct solution in the uploaded versions. So you have the complete, and it's being recorded. Okay. So if you've got 24, Leo, that's the one we're going to do next. Okay. And if there are questions there, we'll go through them. Okay. Questions with this one. Any other questions with this one before we move on? House algebras, was it clear to you guys?
Yes, teacher.
Perfect, perfect. Okay, so I already took a screenshot of this one. Let's jump over then to problem, we're gonna go with problem 22. I think we've got definitely signs with problem 22.
Okay, so the first thing that we need to do is to solve as an inequality. So we add the sign that is greater than 0, the function. So then we reorganize what's inside the parentheses. We get the root and it is -4. And since we have a negative x, we're gonna divide by -1 both sides. And the answer we get is 4. So x is gonna be less or equal to 4. And the answer would be 0,4. Because if we have any number that's greater than 4, the number inside the root is going to be negative. And if we have any negative number as the x, it's also going to be a -1.
Okay, okay. Let's okay, good. Let's just validate. Thank you very much, Anna. Let's just validate a couple of things here. And I want to take advantage of this exercise because we're recording this and we're doing them. And remember that in the end, there's going to be a final exam where we have all of the information and all of the exercises. I want us to practice a few things that we did in Unit 1 that have to do with inequalities, okay? And just to validate the solution, okay? So good. Let's leave that there. Don't move the screen. And so good. You guys, this first part is key to the solution. Okay, this first part that you guys did. This is really, really important. This first part here. So you guys said that this part here is very important. We're asking ourselves the two questions. Is there a denominator? No, there's not. Is there a root? Yes, there is. And so what's the rule? Whatever is inside the root cannot be negative. And that's what you guys are establishing there. x multiplied by 4 minus x cannot be negative, okay? So it has to be larger than or equal to 0. It's very important that you guys noted that it's larger than or equal because it can be 0, okay? So that's correct. Now, I just want us to practice the sign chart method. Just humor me, okay? Let's just practice the sign chart method for a moment. So we've got this inequality, and you guys identify that the roots are x equals 4. I'm sorry, x equals 0 and x equals 4. Those are the two roots, okay? And since we've got the two roots, then we are going to have, well, that line was really not straight. The next line isn't going to be completely straighter, but let's identify the intervals from minus infinite to 0. From 0 to 4. 4. And from 4 to infinite. Just humor me here. I just want us to practice the sign chart method. And we're going to have x here. We're going to have 4 minus x. And we're going to have the product of x multiplying 4 minus x here. Okay. Anna, help me out here. Just help me out here with the signs. Here, so we're going to do this very quickly. From minus infinite to 0, what is going to be the sign of x? This is really
Negative.
negative in 0.
0.
0, correct. And over here?
Positive.
Positive, 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 right? That's easy. Now here in 4 minus x, what are we going to have? If we have numbers from minus infinite to 0, what are we going to get?
It's going to be positive.
Positive, correct. If we've got a 0, positive. From 0 to 4?
No, negative.
Um,
No, positive.
positive, positive, yep. We get to 4?
0.
0. And from 4 to infinite?
It's going to be negative.
Negative, correct. Thank you. Perfect. And if we do the multiplications here, Anna, help me out. Minus times plus.
Negative. 0.
Correct.
Plus 0 and negative.
Negative. Perfect. And so if we look at the sign chart, does the first interval comply with what we're looking for, Anna?
No.
Nope. 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 Correct. Does the last interval comply with what we're looking for?
No.
Nope. Correct. Does the 0 comply with what we're looking for?
Yes.
Yes, correct. Does the 0 to 4 comply with what we're looking for?
Yes.
And does the 4 comply with what we're looking for?
Yes.
Perfect. And so the solution is this here, which is from 0 to 4, which is what you guys got. And we're going to put a happy. Perfect. I just wanted to do this just so we practice the sign chart method. Okay. You got this intuitively, but we demonstrated through a systematic procedure that's correct. So your solution is correct, and we've got the validation here. Was that clear, Anna?
Yes.
Perfect. Don't remove it so I can take a quick screenshot here. Let me do a quick screenshot here. There we go. Perfect. Thank you, Anna, and Team Deathly Signs. By the way, before we move on to the next one, do you guys want to hear the worst graphical joke in history? It's a terrible joke. I anticipate, I'm telling you right now that this is a terrible joke. It's a bad joke that you may use if you wish. It's one of the worst jokes that exist. I'm a father, so these now become dad jokes, I believe. But I'm going to draw it here, and this is being recorded, so you can replicate this if you wish. Let me see, what colors can I use? I'm going to use, yeah, there we go. I've never done this joke with so many colors. I'm going to do it that way. Let's use, no, let's use a blue. Let's use that. Let's use that one. Almost done. Almost done. Okay, there we go. This is the worst joke in history. This is the worst joke in history. Let's see. Let's see. Aime, you're in the classroom. What do you think that is? Aime.
A house with paint and
A house with stuff. No, it's not SpongeBob SquarePants, by the way. Anybody have another guess? And Andres, what do you think it is? It's not me. It's not me. Well, maybe it is. It's a self-portrait. I don't think so, but no, it's not me. What do you think it is, Andres?
I don't know, like a triangle man.
You're close to it. Anybody have a guess? This is the worst joke. I have anticipated to you that this is a bad joke. I
Dorito
never.
Man.
The what?
Dorito Man.
No. I have anticipated to you guys that this is a bad joke. So if you guys say, wow, it's a bad joke. Yes, I told you it's a bad joke. So don't expect it to be funny. Nope. If I'm going to write it down here so we can move on. And this is something, this is a gift from me to you guys. It's the Bermuda Triangle.
I know.
Is that not the worst joke you have ever heard? I didn't say it was going to be a good joke. So if you're like, God, that was a bad joke. I told you it was a bad joke. I never said it was going to be a good joke. So disclaimer, if you think it's bad and it's not funny, it's a purpose. It's not a funny joke. It's an anecdote. It's a graphical anecdote. I'm going to take a screenshot of that and I'm actually going to sign it. So if I ever become famous, you can sell this on eBay. There we go. And we are 30th of September, 2021. There we go. Let's take a screenshot of that. You guys can sell it on eBay. There we go. I'll send that in the chat. It's a terrible joke. Told everybody it's a terrible joke. I only know about 3 jokes and they're the worst jokes ever. I don't remember the other ones, but I do remember this one. So let me send that to you. There you go. That's the Bermuda Triangle. So having shared that with you guys, let's move on to the next one. Now let's go to problem 24, which is, I believe, the one that Leo was talking about. Let's see what you guys did in problem 24.
Teacher, may I go for my charger for my laptop?
Yes, of course. Go ahead. You may use that joke. You can use that joke in the party as well, but after you do the whole other thing where you solve and graph the functions, when you're more engaged in the conversation, then you can bring out the joke, and the person is either going to laugh or is going to leave right at that moment. So let's see, house pi waves. Let's go with problem. I'm sorry, 24, please.
That's you.
Thank you.
Okay.
Okay.
Here we have the function, and we have to find the domain, and the function is f of x equals square root of x squared minus 3x minus 10. Then I rewrite it, and we rewrite it, and then we made it an inequality, and it's x squared minus 3x minus 10. I don't know why I wrote less than, but it has to be greater than. Or
Yeah, that's apparently what I'm seeing. The procedure is correct. That's the only
Yes,
little thing we need to
and
correct.
greater than or equal to 0, and then we have already. I don't know. I don't remember how do you say it.
Factor. We find the roots. We
Yeah,
find
the roots, and the roots are x minus 5 and x plus 2. Then x equals 5 and x equals negative 2. And we did the sign chart. Have negative infinite. Sorry.
Just bring it back so I can do a
Yes.
screenshot. Huh?
We wrote negative infinite, negative 2, negative 2, negative 2, and 5, 5, 5, and infinite. Then here we have we did the shortcut. We find like 5 minus 5 is equal to 0. So before this, everything will be negative, and after this will be positive. Equal, same here, negative, and everything forward it's positive. Then negative times negative, positive, negative times 0, 0, negative times a positive, negative, 0 times positive, 0, and positive times positive, it's positive. So the only restriction we have is that the root cannot be a negative. So we excluded the negative 2 and 5, and the final answer is negative. I mean, it's a negative here. It's negative infinite minus 2, then a bracket union bracket 5, 5 and infinite. But I have a doubt that like if we put a negative here in the x squared, it will become positive. And here the same. I don't know if I'm correct, because the negative 3 times a negative number will be positive 2. And
yeah, that's a good observation, Leo. Let's go into that. Before that, the procedure is correct. Well done. Well done. It's correct. But let's I'm just going to add here the minus. Okay. Let me just add that. Give me a moment, and don't remove the screen. I'm gonna go to your question in a moment. Okay. The procedure is correct. Well done. Now, to your question, you're like, wait a minute. But if I substitute a negative number in the square, it's going to become positive, and the negative number times 3 is going to become positive as well. So why am I excluding those, right? Well, you're not excluding all of them, you're excluding some of them. So for example, Leo, if you grab any number, choose any number, because your solution is correct, choose any number that is less than -2.
-1.
Nope, -1 isn't part of this,
Oh.
isn't less than -2.
It's greater. It will be -3.
-3. So if we substitute -3 there, what happens? If we substitute -3, we're going to get -3 here and -3 here. We're going to get 9 plus 9 minus 10. This is going to be 18 minus 10. This is going to be 8. And that's valid because it's positive, right, Leo?
Yes.
Yeah. And remember, the ones we need to exclude are the ones that make it negative. But now let's go to another number, Leo. Now choose a number that is not within this domain. Meaning choose a number in this range. Choose any number.
1.
1, for example. What happens if we substitute, well, choose a -1, Leo, because your question had to do with negative. No, choose a negative number that's within that range.
-1.
-1, correct. Let's see what happens if we substitute -1. -1, -1. -1 squared is 1. -3 times -1 is +3. -10 equals 1 plus 3 is 4 minus 10 equals -6. This is not valid because it's negative. That's why we're excluding this from the domain, and we're only keeping the other ones.
I think
Yes.
that I get it. The square root of the x and the 3 times the x has to be greater than the -10, so that 10
Correct.
doesn't make the root a negative.
Correct. That's why your solution, your procedure is correct. What we're doing is we're factoring, we're using the sign chart, and then sign chart is going to tell us which ranges contain values that comply with the inequality. And so something that I'd like to note from these two solutions, 22 and 24, that were presented right now, is that the first thing we need to do is that if we have any of the two restrictions, we need to represent them as an inequality. By solving the inequality, we're going to get the correct ranges and solutions. Okay, is that clear, Leo?
Yes, I haven't seen it like that way, that the ones inside make the function negative.
And what you're looking at is the whole polynomial. So regardless of if the x squared is positive, you've got a bunch of other things that are adding and subtracting. And so the whole value has to be positive for it to be part of the domain. And if it's negative, it gets excluded. Okay.
I can stop sharing now. Or
Yes, we're done with this one. Good job. Good job, you guys. Let's go with house jokers. Oh, you guys want extra points for next class? Let's do this for next class. Give me just one moment. Before we go to problem 26, before we go to problem 26, you guys want some extra points for next week? Let's do the following for extra points next week. This is optional, completely optional. Next week, Tuesday, I'm going to give. If you bring a mathematical joke, it can be a meme, it can be any sort of mathematical joke as a house, and you show it, I'm gonna give some extra points to the houses who show a mathematical joke. The worse the joke is, the better. Okay, and we're gonna see about that. But by the way, something very important. It has to be something that it has to be related to something with something mathematical. That's number one. Number two, you have to explain it. Meaning if it's a graphical joke or a meme, you need to explain it. Number three, it has to be something that is not disrespectful or offensive. If it's disrespectful or offensive, then the contrary effect is going to happen, and I'm going to deduct points from the house. Okay, and it's completely optional. Okay, so let's do the weekly mathematical joke of the day. You're not going to be able to beat the Bermuda Triangle. I think that is the worst joke in history. One joke per house. The houses that present, I'm going to give you guys some extra points. Okay. Then go ahead. Let's go with problem number 26 from House Jokers, please.
Okay, right here, I don't know if we need to do the sign chart, but first of all, because we have a root can be negative. So the another rule that the denominator cannot be 0. So that's for why x can be 0. So x is going to be more than 0. And 5 less another number cannot be, well, another number less than 5 because it will be negative. So that's for why x is less or equal than 5 and x is more than 0. So the domain will be 0,5.
Okay, good. Don't remove the problem from the screen. Again, similar to the problem that was previous from last one, I just want us to practice some stuff here. So don't remove don't remove this from the screen. So the first thing that we need to identify is that this part that we have here has to be larger than or equal to 0. So that's the first thing. I'm going to do it. Let's see. I want to take advantage of the better space. So I'm going to do it here. So the first is that 5 minus x divided by x has to be larger than or equal to 0 because we've got a root there. I'm sorry. And for here, we find the two roots, which are x equals 5 and x equals 0. And so let's just, again, to practice, let's do the sign chart here just to practice. And so we're going to have from minus infinite to 0, 0, from 0 to 5, 5, and from 5 to infinite. Those are going to be the ranges that we're talking about. Okay. And over here, we're going to write down 5 minus x, and the division, which is 5 minus x divided by x. Okay. Okay, I think it was Luis, right, that was presenting?
Yes.
Okay, help me out very quickly here, Luis, with the signs. 5 minus x in the first range, is it positive or negative?
Positive.
It is positive. Then for 0?
Positive.
Positive from 0 to 5?
Positive.
5?
0.
0. And from 5 to infinite?
Negative.
Negative. Over here in the 0, this is easy, this is an easy one.
Negative, 0, positive, positive, and positive.
Perfect. And positive times negative?
Negative.
Positive times 0?
0.
Positive times positive?
Positive.
Positive times 0?
0.
And negative times positive?
Negative.
Okay, perfect. The first range is the first range within the first interval within the what we're looking for?
No.
Is the last one what we're looking for?
Or the last one? No.
No? Is the 0 included?
Well, yes.
Remember the denominator?
No.
No? Is from 0 to 5 included? Yes,
Yes.
because it's positive. And is the 5 included? Yeah. Oh, by
Yes.
the way, we've got a mistake here. We've got a mistake here that I need to correct. Here in the 0, it's not 0, it's not 0 here. It's not a number, okay? It's not valid, remember, because it's divided by 0. And so, perfect, that's the solution that you guys got. The solution is from 0 to 5, including the 5, which is this one, that you guys got right here. Okay. There we go. Okay, good. Let me take a quick screenshot of this. Okay, there we go. Questions with this one? Good job, you guys. Questions? Oh, okay, good. Let's jump over to the next one. So we've got problem 28. Give me just one moment. I need to pick up something. Okay, we're back. Please go ahead, team House Algebros.
Yes, so the problem asks us to determine whether the graph in the figure, which is this one, like this weird mix between a W and an M, it's the graph of a function. So we know that a function, it's never going to have two points cross in the same y-axis. So we need to do the line test to determine if it's a function or if it's another thing. So what we did here, it's just try to place lines to determine if it is a function or if it's not. And in this case, it is.
It is correct. Let me just check what you're writing there. The explanation is correct, Daniel. The explanation is correct. Let me just look at what you drew, what you wrote there. So consequently, just remembering about that, if we have a function, the definition of a function is that for every value of x, there is only one value of y, if y is a function of x. So graphically, that's represented, or that can be tested with the vertical line test. So the vertical line test says that if we draw a vertical line in any point of the graph, there should only be one point crossing. That's what you explained very well. So let's just see what you wrote down there. Consequently, if we draw a vertical line at any place in the rectangular plane and this line intersects with more than one point in any given graph, then the graph is not a function. So I think the only thing that we're missing here from this solution, and I'm just going to write it down here, is the solution, which I don't see anywhere, but you said it and it's correct. We just have to write.
I forgot.
Yeah, we need to write down here that the function, this, oops. This is a function. Okay. And just one little thing also here that we're going to correct as well. Just be careful with the, I don't want to be a grammar Nazi or anything like that. Let's just here we've got one extra R here. Okay. Okay. The explanation was a very good explanation. Let me just click save them. Okay, perfect. Yeah, baby JD is commenting on it. Okay, good job and good explanation. So just remember to put the solution there. Okay, good job, you guys. Let's go then with problem 30, please. How deathly signs.
Okay, so the explanation for the answer is that if we draw a vertical line in the rectangular plane, the line intersects with more than 1 point in the graph, which is why the graph is not a function. And here we drew 2 vertical lines, and we can see that there's like 1 point here and 1 point here, and the same thing here. There's 2 points that intersect.
Perfect. Same explanation. Same explanation as the previous one. So the function, if it's a function, if y is a function of x, then we can only have one value of y for each of the values of x. Graphically, we see that we can test that with a vertical line test. For this graph, if we draw a vertical line, we're going to see that the vertical line intersects in more than 1 point. That means that the graph is not a function. Correct. Well done, you guys. Well done. Okay, good. We're moving along nicely. Let's go with problem 32. House pi waves, please.
So in problem 32, it says that we have to use the graph that is given to us of the function f to find its domain and range. So the graph is there, and we know that the domain are the values that takes x. So it looks like here we have from -1 to 1, and it doesn't seem like it goes further than that. So the domain for x, it would be bracket -1, 1. And for the range are the values of y, and this would be from -infinite to infinite, because it looks like the graph may go on like further, like up and down. But we were not really sure if this was closed. So maybe it is from -pi and over 2 and to pi over 2, but we were not really sure.
Okay, good job, Alejandro. And let's comment a little bit about that. The logic that you followed for the domain is actually the same logic we're going to follow for the range. So we need to interpret a few things in the graphs, and because we're going to be talking about graphs a lot in the next topics. And so if we look at that graph, we notice one thing. This type of graph that we're looking at right now is what's called a discontinuous graph. It means that it's a graph that is not going from -infinite to infinite. It's like a graph that's been cut off in a couple of points. Imagine a string that's been cut off in a couple of points. So the graph only has those points that we're seeing. So the logic that you guys followed, you say, okay, well, looking at the graph, it seems that in X, it's starting off in -1 and it's ending in 1. So correct, the domain would be from -1 to 1. Now, how do we know it's in a bracket? We know it's in a bracket because do you notice that the circle there in the graph is filled in? The circle is filled in rather than, give me a moment. This is an art, by the way, of holding this with the chin and being able to write. So here the dot is filled in rather than being open. If the dot were open, it means the value is not included. So if the dot were not filled in, then we would not have included the -1 and 1, and it would have been parentheses. But since the dot is filled in, that means that those values are included. Okay, that's one thing. So the domain is correct. Okay. So the domain here, this is correct. Don't remove the slide. Now in the range, one thing that I have to comment right now, if we're establishing an interval with infinite, we never use brackets with infinite. Okay, because I'm going to ask you a trick question, Alejandro. What is the value of infinite? Do you know the value of infinite?
It could be any value.
But yeah,
But that, yes, like any value.
Any value, and you don't know. Do you know when infinity ends?
No.
Nope. So it has to be infinity is always an open interval. It can never be a closed interval because infinity never ends. So we never represent an infinity interval with brackets. However, going back to this graph here, the range is also going to be limited, and it's going to be limited to the values of the domain. Remember that the range are all of the possible values of the function according to the domain. And the domain is limited to -1, 1, and we see that for -1, we have minus pi divided by 2, and for 1, we've got pi divided by 2. Okay, so I'm going to write this down over here so I don't mix it up. So in the case of the range, the range is actually going to be from minus pi divided by 2 to pi divided by 2. And that's going to be a bracket because of the dot that I just mentioned. The values are included because the dot is filled in. Okay. Let's see there. Just give me a moment. I'm just being OCD here. I didn't like the way my 2's came out. Okay, is that clear? Alejandro and company? Okay, don't remove it, please. Let me just take a quick screenshot here for the modifications. Okay, questions? Was that clear, Alejandro?
Yes.
Okay, perfect. Let's okay, perfect. Let's go with problem number 34. Go ahead, you guys.
Okay, so we have problem number 34. We're given a graph and we have to determine the domain and range just based on the graph is made. So we know that for the domain, it starts from minus infinite and it goes all the way down to -1. But since we cannot see where it stops, we cannot include number 1. So we have to use a parentheses, and then we have to use a union for the interval in between -1 to 1. And then another union for 1 to infinite. So basically, we cannot determine the values in -1 and 1. And for the range, well, it goes all the way down to minus infinite and all the way up to infinite. And that would be it.
Okay, good job. Don't remove the slide, please. Good job. A couple of things that I want to note here. These lines, these dotted lines here, have a name, and we're gonna be talking about that in the next topics. Does somebody know what these dotted lines are called? You can say it in Spanish if you don't remember the name in English. They have a weird mathematical name. Does somebody remember what they're called in a graph?
Asyntotas.
Yes, asyntotas, or in English it's asymptotes. What do asymptotes represent? Does somebody remember? What does an asymptota represent in a graph? Anybody?
It's the point where the line of the graph never passed.
Exactly. An asymptote represents an imaginary line that the graph or the function is never going to touch that line, but it's going to be closely getting to that line until infinite, but it's never going to cross it. These are called asymptotes. If we're talking about domains, the asymptotes are values that are removed from the domain. So the domain is correct. We've got values here. -1 and 1 are asymptotes, so those are removed. And so the domain is what's indicated here. That's correct. Now let's talk a little bit about the range. Okay, and let's look at the range. The range are the possible values of y. So let's make a slight correction here for the range. Let's start from the bottom down, because right now we're in the y-axis. I agree with you. We're going from -infinite, and we're going from -infinite. And then what value do we reach? What value are we reaching there in the graph?
0.
0. Is the graph touching 0? No.
I don't know.
So, well, actually, if we're looking at the graph, it's not touching 0. It's never crossing 0. So actually, the x-axis is also an asymptote. Okay, the x-axis is also an asymptote. So we're going from -infinite to 0. And then, do we have any values? What value do we have here? What value is this?
1.
1. Is there any part of the graph between 0 and 1 in the y-axis?
No.
No. So actually, there's nothing between 0 and 1. So that's not part of the range. And so we're going to have, the following. We're going to have values from 1 to infinite. Now, looking at the graph, am I going to include the 1 or not?
Yes.
Yes, no?
Apparently, it's crossing the 1, isn't it? So I am going to include the 1. So the range would be from -infinite to 0 and from 1 to infinite. Okay. Is that clear, you guys? Okay, don't remove the slide. Let me take a quick screenshot here. I don't want to be in the screenshot. There we go.
Teacher,
Yes, go ahead, please.
I have a question.
Go ahead.
So on the range, we don't include the third line graph? Like, for example, you have the other ones at the bottom right.
Oh, but that's a good question. Well, if we look at that one, my screen was down, so it was Arturo, right?
Yes.
Yeah, so let's look at that one, Arturo. And remember, we're looking vertically. We're going from so let's do this exercise because Arturo's question is correct. Let's look at each of the graphs separately. If we look at this graph, we're going from -infinite to 0. Okay? If we look at this graph, we're going from 1 to infinite. And what happens when we look at the graph here on the right, Arturo? We're also going from -infinite to 0. Would you agree? And so actually, if we want to do this very systematically, Arturo, right now this graphic has some sort of symmetry. But let's assume that it didn't have symmetry. We could do what we just did. We established the 3 ranges and then we combine them. Okay? The fact here is that the range of the graph on the left, bottom left and bottom right is the same one. But we could have another graph that would be up here, I don't know, here. If that were the case, then we would need to analyze the 3 of them. Okay? Was that clear, Arturo?
Yes, yes, I understood. Thank you.
But yeah, that's a good observation because there might be a case where the graph isn't necessarily symmetrical. Okay, good. Good job. Good job, you guys. Let's go then with problem. I think the next one is problem 48.
Teacher, on this one, I'm gonna present, but I accidentally did the wrong question. I did 46 instead of 48. And I realized right now when we were doing the other problem.
So baby's crying because he needs the gas. Don't worry, let's present 46. They're mostly the same problems. I think they're the same type of problem, so that's fine.
Okay. So on this one, it says problem 48, but it's actually 46. This one is, the question on top is problem 48, but for the problem 46, it states that it's 2x minus 3x squared plus 8x plus 16. And it is asking us to find the x-intercepts and the y-intercepts. So to find the x-intercepts, we first have to make the f of x equal to 0. Once we do that, we basically solve for x. Once we do that, we realize that 2 of x minus 3 is equal to 0, while the x squared plus 8x plus 16 is equal to 0, and we solve for x right there. And the x is going to equal x is 3 over 2, 3/2. And the other side is going to be x equals to -4, which are the both x-intercepts. And to find the y-intercept, you have to make the f of x equal to 0. Once the x equals to 0, all the x's in the problem equal to 0. So the f of 0 is equal to 2 times 0 minus 3, 0, or minus 3, and then the other parentheses is 0 to the square root plus 8 times 0 plus 16. Once we solve for that, the answer is going to equal to f of 0 is equal to -48, which is the y-intercept.
Okay, good job. Good job there. So it was 46, the one you did, okay? So basically what we're doing here is that we need to find the x and the y-intercept. The x-intercepts are basically going to be the roots, okay? The roots of the function, and we find the 3 roots in this case that we've got there. We find the 3 roots, which would x equals 3.5, and then for the polynomial, that's a perfect trinomial. So we've got x equals -4. And the y-intercepts, we're going to find those for the situations where x is 0. So we substitute 0 into the function and we get -48. Okay, so correct. It's fine if you did problem 46. All of this section of problems are to find the same thing. So it's just a different function. I'm sorry if you didn't do 48. Okay. I'm sorry, but the procedure is the same. Okay. Good job, you guys. Thank you. So now let's go with problem 50, please. There we go. I hope you guys didn't hear that, but that's what happens. That's what you need to do with the baby once you finish eating, or else they get really fussy. So let's go with problem 50, please.
Okay, the first thing we did is to find the interception of x, and we have the equation. We elevate all the equation to a square, so equals to 0. Then we multiply 1/4 by all the equation, and then we use the general formula to find the interceptions of x, and the results are going to be x equals to 3 and x equals to -1. And then for the interception of y, we did it, but the square root gave us negative. So that's why we didn't find an interception for y.
Perfect, perfect. Well done, well done. So the same as the other one for the x and y intercept. For the x intercepts, we're basically finding the roots. You guys use the general formula there to find the roots. You could have factored as well, but it's x equals 3, x equals 3 and -1, correct? And for x equals 0, when correct, when you substitute it, you get the square root of -3, which is an imaginary number. Therefore, there are no intercepts in y. So that is correct as well. Just one thing here that I'm going to correct. We're not, so this isn't necessarily football. So we're talking about intercepts, not interceptions. Okay. So these are the intercepts. Okay. But that's not a deal breaker. Okay. Good job, you guys. Good job. Well done. Okay. Okay. So we've still got a couple of problems left, but we're going to leave those for next Tuesday. Okay. Which is 58 and 60 with pi waves and jokers. I'm still going to upload the solutions to the workshops with the corrections later today, so you have them. Remember, the homework task 6 is for next Tuesday. Estrella has tutoring today and next and a moment here. Estrella has tutoring today at 5 and today at 5. Yeah, today at 5. Okay, so if you have questions about the homework tasks, you can log in to Estrella's tutoring today. Okay, I'll see you guys next Tuesday. Have a good weekend. Stay safe. Bye bye. JD says bye bye. He's asleep. Bye bye. See you guys.